Section 4.2 is about modeling with linear functions. And so remember, we can write a linear function in different ways. Most typically, we write it in slope-intercept form, or f of x equals mx plus b. But any function that has a constant rate of change is a linear function, and we're going to just see in this section how we can determine whether we have a linear function to model a given scenario. Okay, so for number one, suppose a payment plan for an appliance is provided. The total amount paid, P, can be written as a function of the number of months, M, as P of M is equal to 100 plus 50M. Okay, so we first want to know what is the slope of this line. Okay, we see that this is in slope-intercept form. More closely if we wrote it like this, 50m plus 100, but either way the coefficient of the variable is going to be the slope of the line, and so the slope is 50. And in part B, how many dollars are paid each month? So we go back to the slope, which is how much. Okay, well, if the slope is 50, and we can write this as a fraction 50 over 1, that's going to be change in the total amount paid per month, so over change in number of months. Okay, and so that tells us that so the amount paid is $50 a month for this appliance. We want to know what is the Y-intercept. Okay, so we go back to our function, and the Y-intercept occurs when M is equal to 0. But in our equation, it's just B, and so if you just cover this term up, and we see that the Y-intercept B is 100. Okay, written as an ordered pair, that would be 0, 100. And what that tells us is, no matter what, even if you have paid no months on your bill, your initial deposit is $100. And part D, after how many months will the total amount paid be $450? Okay, so we go back to our formula. We're given a p-value, and so this equation is 450 equals 100 plus 50m, and we want to solve the equation for m. So the first thing is to subtract 100 from each side, and so 350 is equal to 50m, and then divide both sides by 50. And therefore the number of months is 7. So let's take a look at another example. The table gives the value of an automobile, V, according to its age in years, A. Okay, and so we can see 0 years, the value is 17,800. After 2 years, it's 15,200, etc. And so we want to write a linear function in slope-intercept form to fit this data. Okay, the first thing that I want to do is to ensure that this data would fall in a straight line. And so we're going to determine whether the rate of change is constant. So I'll make a third column, which is delta V over delta A, or change in V over change in A. And we use the first two ordered pairs to get this rate of change. And so you can do a little scratch work on the side that it's just the slope formula. So 15,200 minus 17,800 divided by 2 minus 0. And that's negative 1,300. And the next 2 points will do the same thing. 13,900 minus 15,200 divided by 3 minus 2. And again, that's negative 1,300. And one more time, the last 2 points, that would give us 10,000 minus 13,900 divided by 6 minus 3. And again, that is negative 1,300. And so because all three of these values match, that means the rate of change is constant, and therefore this is a linear function. Well, we want to write a linear equation for this function, now knowing that we can write it. And so we're going to say V of A is equal to, the Y-intercept is one number that we need. But luckily, it is given to us in the table, and so the Y-intercept is 17,800. The slope is a number that we just found, which was the rate of change, and negative 1,300. So writing the equation in y equals mx plus b, or slope-intercept form, we get negative 1,300 a plus 17,800. In part B, we're asked to graph the function. So one option is just to pick a couple of clear points from your table and then make sure that your line passes through them. Okay, so I have the Y-intercept, which is 0, 17,800. Okay, so I'm just going to do my best to estimate where that would fall on my grid, okay, which is very close to 18,000. And then 6, 10,000. So 6, 10,000. So it's above 9,000 and somewhere between 9 and 12. So maybe around here. And then we'll draw the line through those 2 points. Another important point that may be helpful is to find the X intercept, or A intercept in this case. And you can do that by setting V equal to 0. So we have 0 equals negative 1,300 A plus 17,800, and solve for A. And I'm just going to round to one place. That's about 13.7. Okay, so then you know that your X-intercept should pass through a point over here at about 13.7. And lastly, in part C, we want to explain what the slope and the V-intercept mean in the context of the problem. Okay, so I'll start with the slope. We said the slope was negative 1,300. And if I write it as a ratio, negative 1,300 over 1, then that would give me the change in V, the dependent variable, over the change in A, the independent variable. And so if I think about what these stand for, the change in value and then the change in age. And so because the age of the car was in years, each year, every 1 year, the car's value decreases by $1,300. And we also want to explain the V-intercept. And so that V-intercept was whatever our B was earlier. We said that that was 17,800. That occurs when A is 0. So right when this person purchased the car, its value was $17,800.